Welcome to lesson 41. We're in 41A today. Reciprocal trigonometric functions. So sometimes we're going to have to use the reciprocals for our trig functions, sine, cosine, and tangent. So for cosine, like let's say we have the cosine of theta, just whatever degree that is. The reciprocal for that would be 1 over the cosine of theta. The name of that reciprocal is going to be called a secant. So that would be SEC of theta. So the reciprocal of cosine of theta is the secant of theta. We have one for the sine also. So the sine of theta, the reciprocal for the sine of theta, that'd be 1 over the sine of theta. That is called the cosecant. So CSC of theta. It's just the reciprocal of theta, or of sine of theta. And for tangent of theta, whatever degree of measure that is, it's just the fraction 1 over tan of theta, not tan. And that is called your cotangent, COT of theta. And we remember the definitions by using SOHCAHTOA for each of these, right? So let's do that up here. SOHCAHTOA, right? So it would make sense that the inverse is going to be the flip. So the cosine, let me come up here a little bit. Tell you what, I'm going to bring this down. There we go. That's going to make it a little bit easier to see. So when we have the cosine of theta, right, we know that it's CA, right? So this is CA, typically, and that is the cosine is equal to the adjacent over the hypotenuse. But when we have the secant of theta, it's going to be reversed. So the secant is going to equal the hypotenuse over the adjacent. Okay, so it's instead of ka, it's sha. Ka sha, right? So we can put sha right here for this one, so we can remember which one it is. And for sine, you know, sine is so. So the sine is equal to the opposite over the hypotenuse. So the cosecant, the CSC, is going to be equal to the hypotenuse over the opposite. So that's actually going to be the CHO. The CHO. CHO, SHA. So that's how you would remember the inverse. So let's do the tan. The tan is TOA. And typically TOA or tan is going to be the opposite over the adjacent. But the cotangent is going to be the adjacent over the opposite. So that's KO. So KO. CHO, SHA, KO is the inverse, or not the inverse, the reciprocal. It's the inverse mathematical locations, but it is the reciprocal to your trigonometric functions. So you might want to write all of this down. Specifically, I would say, let me erase this so it makes a little bit more sense. I would put this down somewhere so that you have this. Now we might not use CHO, SHA, KO. You could still do SOHCAHTOA and then just reverse it. But CSC, which is your cosecant, is the first letter of each one of these. So that helps me to remember the order, which tells me the names, cosecant, secant, cotangent, under tangent. So that helps you to see it if you need that. So go ahead and put those in your notes and we'll do a couple little practice problems. All right, I'm going to assume that you have paused and written all this down. So let's clear the page and do a practice problem using these. All right, so 41.1. We are going to draw the appropriate triangles and evaluate the secant of 330 degrees plus, excuse me, the cotangent of 480 degrees. So the trick is to remember which one goes with which one. All right, that's kind of the thing. So secant is the inverse of cosine. So if the secant of 330 is co, then that's going to be hypotenuse over opposite, or adjacent, instead of adjacent over hypotenuse. So we'll get to that. Let's pull our notes up. But first, let's deal with these degrees here and get where we need to get. So let's draw our reference grid or reference system. And let's figure out where the secant of 330 degrees lives. So if we go all the way around, we know that it's all the way 360 from our terminal side. And this is a positive degree, so it's going to be from our terminal side all the way around would be 330 here. So we'd have another 30 degrees before we made a full circle. So that means we have 30 degrees left right here. So that means we have a 30, 60, 90 triangle. And with our 30, 60, 90 triangle, we know the hypotenuse is 2. We know that the 60, 90 side is 1. And we know that the 30, 90 side is the square root of 3. Now, because the 1 is down here below the x-axis, it's going to be a negative 1. Right? Now, this is where we remember what secant means. And secant means hypotenuse over adjacent. So that's going to be 2 over the adjacent is going to be the square root of 3. So 2 over the square root of 3. And we want to normalize that. So square root of 3 over square root of 3, we're going to multiply that. And then that's going to give us 2 times the square root of 3 over 3 for this first degree here, plus. Now let's worry about the cotangent of 480. First, let's figure out where 480 lives. So let's draw our Cartesian coordinate system. And we know that 480 is greater than 360, and this is a positive degree. So I'm going to say 480 minus 360, and that leaves 120. So I know that 120 is greater than 1 quadrant, so I'm going to subtract 90, and that leaves me 30 degrees into the next quadrant. So 90 and then 120. So this is a 30-degree angle here. So that means this is a 60. And this is a 30, and this is a 90. So I just line it all back up. Between my 90 and 60, I have a negative 1. Between my 30 and 90, this is going to be a positive square root of 3, and 2 is the hypotenuse, and it's always positive. Now the cotangent is going to be the reciprocal of TOA, which is opposite over adjacent. So that's going to be adjacent over opposite. So the adjacent to my 60 degree is negative 1. So that's going to be negative 1 over the opposite, which is the square root of 3. Yeah, adjacent over opposite. We don't use the hypotenuse with the tangent. So we got to normalize this. So this is going to be times the square root of 3 over the square root of 3, which is going to equal negative square root of 3 over 3. So this is going to be a minus now instead of a plus because we have a negative value. Minus the square root of 3 over 3. Well, guess what? When there's nothing there, there's a 1 there. So 2 minus 1 is going to be 1. So it's going to equal 1 times the square root of 3 over 3, which we know we just erase this invisible 1 right there. That is our answer. Let me double check and make sure I'm right. And yes, that is the correct answer. Square root of 3 over 3. So it's not that hard. We just have to kind of flip it. We just flip the relationship for each one of them. That's all we're doing, is that rearranging of where we put the values. Let's do 41.2. So in 41.2, we are going to evaluate 2/3 times the cosecant, which is sine, times negative 3 pi over 4 minus the secant, which is cosine, in a reciprocal of cosine, 11 pi over 4. So remember, with this pi, all we have to do is substitute in the value of 180 degrees. So 2/3 the cosecant of negative 3 times 180 divided by 4 minus the secant of 11 times 180 divided by 4. So when we do all of that math, what we end up with is let's see. Get my calculator out, because they didn't do this part in the book, but we know we can do that. So I'm just going to go ahead and do that. Negative 3 negative times 180 divided by 4 is negative 135. So 2/3 the cosecant of, what did I say that was? Negative 135 degrees minus the secant. And we're going to do this one here. 11 times 180, because it's a positive, equals this divided by 4 is 495. So 495 degrees. Now we just have to figure out where they live. So I have, this one is negative 135. So I'm pretty confident that's going to be in the third quadrant, because this would be 90, right? So I'm going to add 90. We're measuring from the, oh my goodness, I forgot the word. Initial. We're measuring from the initial side. I don't know why I can't remember that. We're measuring from the initial side because we're going clockwise instead of counterclockwise, which is positive. So we're going the negative way because this is a negative degree. So negative 135. So I'm going to say negative 135 plus 90 to tell me where this is living on this side, coming from the initial direction. So that would be 5, and then this would be 4. So negative 45 degrees. So negative 45 degrees puts me right here. This is a 45. So which means this is a 45 relative to the x-axis, because everything is about the x-axis. It thinks it is so special. So we know this is 1, this is negative 1, and this is going to be the square root of 2 for the hypotenuse. We know that. All right, so now we can find the cosecant of this 45 degree angle based on where it lives. So the cosecant is going to be hypotenuse over opposite. So this is going to be 2/3 times the hypotenuse, which is the square root of 2, over the opposite, which is a negative 1. And then this is going to be minus the secant of 495. Well, that 495 is greater than 360, and it's positive, so I'm going to subtract 360 from it to figure out where this lives. That's 3, and that's 1. So that's a 135-degree angle. So that tells me that this is probably in the second quadrant, because if this is 90, then that's going to be 45 that way, because we already know that 135 minus 90 is 45. So it's going to be a 45-degree angle this way. So this is going to be 45 if this is 45 relative to the x-axis. This is +1, this is -1, and this is the square root of 2. All right, so the secant is going to be hypotenuse over adjacent. So hypotenuse is the square root of 2 over the adjacent, which is -1. All right, so that's where we are now, and this is what we have to solve. So we are going to multiply, so that gives me 2 times the square root of 2 over -3. We know this can never be negative, so we multiply the whole thing by -1, which transfers the negative sign up here. Same thing here. This can never be negative, so we're going to multiply the whole thing times -1. Moves the negative up here. Negative and a negative is a positive, so this is going to be plus the square root of 2 over 1. We need to have the common denominator in order to combine these. So we're going to multiply everything by 3. So that gives me 3 and 3 if I multiply by 3 here. So -2 and 3 gives me a +1. So our answer is going to be the square root of 2 over 3. And that is the correct answer. Yay, we did it right. So proud. All right, so you see it's not that hard. It's really not that difficult. We're taking everything we've learned up to now, and we're just inverting it. We're using the reciprocal fraction. We're flipping where we put everything. That's all this is. And because it has a different name, it helps us to see which one we're doing. We just have to learn how to match up the different name to the reciprocal fraction. Let's do one more, 41.3. So we're going to draw the appropriate triangles, and we're going to evaluate the secant of 10 pi over 3 plus the cosecant of -7 pi over 2. Hang on a second. Roscoe, be still. Hush. Lay down. Lay down. Be a good boy. All right. I don't know what he's doing. He's making a racket. All right, so first things first, let's get rid of pi. I just like doing that straight away. So this is going to be 10 times 180 divided by 3, and the cosecant is going to be -7 times 180 divided by 2. Sorry, I'm laughing. He's licking my toes. Strange little dog. Well, he's not little. He's like 97 pounds, so he's a big boy. All right, so let's do the math here and see what we have for our degree of measure. So 10 times 180 divided by 3 is 600 degrees. That is a large rotation there. So 600 degrees, we know that's an over rotation. So it's more than once around. And we're going to do the cosecant, and here we have, clear this, 7, and it's negative, times 180 divided by 2. And it's going to be a -630 degrees. So now we need to figure out where these live. This is positive, so I'm going to subtract 360 to figure out where it lives. So that's going to be 0 minus 0, and 60 minus 36 is going to be 24. So positive 240 degrees. So that's where this is. SEC 240 degrees. Plus CSC, and this is -630. So I'm going to add 360 to this. And 13 Hello, I'm losing my mind. So that's going to be 270. Is it right? Yeah, 270. So it's a negative 270 degrees. So this one, negative 270 right there. So this one, let's figure out where he lives. I'm pretty sure he's going to be in the third quadrant. And actually, we're just going to make sure of that. So yes, 180 would take away 2 quadrants. So that would be 0. 14 minus 8 is going to be 60. So he is going to be 60 degrees into the third quadrant. So right here, 60, and then this is relative to the x-axis, not a right angle. This makes this a 30. So everything is negative. So we have this is the 2. This is negative 1, and this is negative square root of 3 for this one. And the secant, let me look back at my notes. I encourage you to have your reference notes handy. So the secant of 240 is going to be the hypotenuse over the adjacent side. So 2 over negative 1. So 2 over negative 1 plus, and then the cosecant of 270, this is exactly on the third terminal. It's a terminal angle. So it is exactly right here, right? That's where that is. So because it rotates and it goes all the way around and then around 3/4 of the way, and it stops right here. This is where we are. So I'm trying to remember the terminal right here. I think this is 1, and this is 1, and this is 0. If I remember it correctly. All right, so the hypotenuse, when you have this 270, this is going to be a negative 1 because that is the number we give it. And your x value right here on the x, that's going to be a 0 because it has no width. And then your y value, which is how far down it comes, is going to be a negative 1 also. So I knew there was 2 negative 1s there, but I couldn't remember which one was which. So the x is 0 because it has no width. So wherever it has no width, that is where the 0 occurs when you have a terminal angle. I said that as much for my benefit as yours because we really haven't done a whole lot of terminal angles in order to practice that. So here's where we get to do that. So, so which one is which? This is the hypotenuse. And then this is going to be the degree, or this is going to be the, how far it would stick out relative to the x-axis. And then that would be, yeah. So 0 would be your adjacent, and this would be your opposite. So this is your adjacent side, and this is your opposite side. So that's going to help us figure this out. All right, so the cosecant of 270, which happens to be a terminal angle, is going to be, the cosecant is hypotenuse over the opposite. So our hypotenuse is -1 over -1 because the opposite is -1. -1 over -1 is a +1, right? So +1. And 2 over a -1, a positive over a negative, that's going to be a negative. So that's going to be -2. -2 plus 1 is equal to -1. I do believe that is the correct answer. And it is. We got it right. Yay! It took a minute, but we had to figure it out. That's all right. Sometimes it takes a minute. So let's do 41.4, and that will be the last one in 41A, and we'll move on to 41B. Let's clear the page. So 41.4, we have got to evaluate the cotangent of 17 pi over 6 minus the square root of 6 times the cosecant of -9 pi over 4. So right away, I'm going to insert the 180 here. Cotangent of 17 times 180 degrees divided by 6 minus square root of 6 times the cosecant of -9 times 180 degrees, and I didn't do my other parentheses there, over 4. So let's evaluate those by pulling up my calculator. 17 times 180 divided by 6. So the cotangent of 510 degrees minus the square root of 6 times the cosecant of 9 negative times 180 divided by 4. -405. All right, so both of these are over rotations of the 360-degree coordinate system. So we're going to subtract from 510 to figure out where this lives. I'm just going to pull up my calculator because that's a little faster, and this is, it's starting to take a minute. 150. So we have the cotangent of 150 degrees minus square root of 6 times the cosecant of, now this is 150. Now we have a -405. So I'm going to add 360 degrees here, and that is going to give me a -45 degrees. I could actually do that one in my head, which is awesome. So -45 degrees is where we are with this one. So now I could pretty much figure out where these two live. So I know that 150 is greater than 90, but less than 180. So I'm going to subtract 90 from this and figure out where in the second quadrant this lives. So this is going to be 60 degrees into this second quadrant. So I'm going to draw the second quadrant. And so it's going to be 90 and then 60 more, which means that relative to the x-axis is the 30 degree, and this is the 60 degree, this is the 90 degree. So we have a hypotenuse of 2, we have a square root of 3 here, and we have a 1 here. The square root of 3 is the only thing that's negative. So there are our values. So again, looking at cotangent, cotangent is going to be the adjacent over the opposite. So -3 over 1. So negative square root of 3 over 1. Right? Which we know that anything over 1 is a whole number, so we can just write the negative square root of 3 as our answer. Minus the square root of 6 times whatever this is. So let's find where this lives. And I'm pretty sure this is the fourth quadrant because it's -45 degrees. So we're measuring from the initial side here, going clockwise. So this is going negative. So -45 degrees, that's going to put us right here at a 45-degree angle relative to the x-axis. So this is a 45-degree angle also. This is a 90-degree angle. This is a +1, -1, and a square root of 2 for for our reference triangle. All right, so that tells me the cosecant is going to be the hypotenuse over the opposite. So the hypotenuse is square root of 2 over the opposite, so that's going to be over a -1. So that means we have a negative square root of 2. And that is where that lives. Now, is that, oh, this is times -6, negative square root of 6 times the negative square root of 2. So that's going to be, actually this is negative, or this is just 6. This is -6 times the square root of 2. So negative square root of 3, and this is going to be, let's see, negative times negative is positive. So it's the positive square root of 12. Square root of 12 can be simplified into square root of 4 times the square root of 3. So that would become a 2. So then this would turn into, this is a -1 times the square root of 3. This would be a positive 2 times the square root of 3. So a -1, positive 2 equals a positive 1 times the square root of 3, which is just a square root of 3. And that is the answer to 41.4. All of that just to get that. I know that's so frustrating, isn't it? You do all of that and you end up with this little bitty answer. You did all of that scratching around to figure that out. But we figured it out. So pat yourself on the back. You did a good job. All right. So that's all we have for 41A for the reciprocal trigonometric functions and how to use them. So be sure to put all of those reciprocal definitions into your reference section of your notebook. You're going to want to have those, you're going to want to have those on hand because we are going to do more of them. And I'll see you in 41B.